Sass class with Amanda. Hey.
So in this video, we're just going to work through an example using the information from the categorical variable video. Okay, so now we have a new data set. It's about the mental status of school-age children. We have 100 children, and they're from a random school called A. So let's just look at the table. Okay, so we have mental status listed: well, mild symptoms, moderate, and impaired functioning. And here we have number, this is not a no, number of children with that status. Okay, so well has 24, mild symptoms has 14, moderate is 35, and impaired functioning has 27. Okay, so let's go ahead and start with our two questions. Question 1, who are the individuals? So, what is the data describing? Well, the context says we have data on the mental status of school-age children. So to me that says the data is describing the mental status of school-age children, but it's not describing, school-age children or mental status. That makes no sense. So to me this says the individuals are the children who are school-aged. So the 100 school-aged children. And it sounded like I jumped through a lot of hoops in order to justify that these are the individuals. That's probably true. So in some problems it'll be more obvious than others, but you should try to justify it in your own way why school-age children are the individuals. So our second question is, what does the number represent? And the reason why this is a question is because it'll determine whether this is indeed a categorical variable. And this will become more important later after you've watched the quantitative variable video, because there will be numbers in those data sets as well. And you need to be able to justify whether something is quantitative or categorical in your near future. Okay, so this number represents the number of students with a certain status, which tells me that these 24 individuals have the label well for mental status, and these 14 have the label mild symptoms, and these 35 has the label moderate, etc. So the number represents the count of individuals with label, and I'm just going to call it I for a lack of a better general phrase. So this example asks, what is the best graphical representation for our data? Okay, so let's just recall from our other video that we know about bar graphs and we know about pie charts for categorical variables. And like we said a few seconds ago, we know that our variable is a categorical variable because it is a count of individuals that fall within certain labels. Okay, so we can choose one or the other. Okay, I'm going to choose a bar graph. Okay, so when you make a selection for your data visualization, you need to be able to justify why. The reason why I'm not using pie chart is because we have two numbers, 24 and 27, which are rather difficult to distinguish between when you create a pie chart by hand. Okay, if we were doing a pie chart in R, then maybe it would be more distinguishable, but I feel like the percentages or the slices of the pie for 24 and 27 are difficult, and so I'm not going to use a pie chart you're more than welcome to do so yourself. It's not a bad choice, it's just not the choice that I'm making. Alright, so since I'm choosing a bar graph, I need my vertical axis and my horizontal axis. And remember, our horizontal axis has our labels. So I'll use a W for well, an MI for mild symptoms, an MO for moderate, and an IF for impaired functioning. Right? And remember that our vertical axis represents the number of individuals. So here I'm going to just say frequency. So the number of individuals, actually I'll just stick with, because that's sort of confusing with our histograms. So here I'll use number of individuals that fall within a certain label. Alright, and so now I'll draw our heights. Okay, so what do we have for students who have well mental status, or mental status of well? We have 24. So 24, let's say that's around here. And mild has 14, which is 10 less than 24. Moderate is 35, so it does have the tallest bar. And impaired functioning has 27, which is slightly higher than 24, and a lot less than 35, 27. Alright, and so for any graph, we want to be able to give it a meaningful title. And so we're just going to give the title mental status of 100 kids.
My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. We live in a world of technology. They're collecting information on your humanity. Social networks, gaming, and in-home software.
Hello, Alexa.
Statistics helps us be more aware. Haters gonna hate my spicy lyrics. Why you gotta be so mean? Pulling me towards your extreme moods, but the median never fails to center me. 50 to my left, 50 to my right. Got these correlation and regression tools, forget them fools. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. The mean of the means is the mean. The mean of the means is the mean. The mean of the means is the mean is the mean of the means is the mean is the mean. Be careful not to fall in love. Statistical seduction from above. Your shape so beautifully symmetric to the eye with a single peak so high. I hypothesize and can testify that your p-value is the smallest I've seen. Mix that with a large power and I reach ecstasy. Your residuals defy the rest. A small scale randomized pattern tells me you are the best fit. My name is Llama, and I'm here to teach you stats, skilling you up with the cold hard facts. My confidence is so high, 95%. My margin of error so nil, 1/10. Can you feel me? Can you feel me? I estimate your population parameter based on only one sampling. Oh, haven't the frequentists told you about me? We live in a world of data, attempting to understand life by statistical strife. The implicit bias of cops, success rate of them jocks, medical advances, and AI romances. Statistics.